No niin, hei kaikille ja tervetuloa takaisin. Seuraavaksi meillä on siis Tuukka Vartiainen IBM:ltä puhumassa tekoälystä ja koneoppimisesta. Seuraava esitys on englanniksi, eli myös englanniksi alustus. Next we will have Tuukka Vartiainen from IBM. He is a software client architect and he's gonna give a super interesting talk about AI and machine learning. One reminder, if you have any questions you want to ask from Tuukka, you can send questions to him from the event webpage under the stream box, or you can find also the form link via YouTube under the comments. But yes, I'm ready. Tuukka, are you there?
Yes, can you hear me?
Yes.
Very good. Okay, so first of all, I'd like to welcome all of you from my part, and it's an honor to be here. Haven't had this many presentations lately due to some pandemic going on, so it's good to be back and talking to you guys again. I usually give recommendations during this pandemic for people in my team when they go live on presenting to crowds, that they would at least, have the decency to take out some scissors and maybe cut some kind of holes in their beard to see the eyes. So I hope I've done a good job with that, and I can maybe be recognized by you guys over the line. I'm going to talk about AI and machine learning and their role in digital transformation, which is happening in a lot of industries and public services and all the different kinds of services out there. So let me get started with this show. So like Anna just mentioned, my name is Tuukka Vartiainen and I'm coming from IBM. I'm an enterprise architect there in cloud and cognitive, so that's my role. I've been designing AI solutions and a lot of other kind of things for the past 20 or so years, and well, AI has been coming up recently more in the past 6-7 years mostly, but anyways, I know a lot of stuff in the banking industry, in insurance, but I've also been working with other industries and other kind of companies. So yeah, it's interesting, the different parts where we use AI and machine learning these days. If you want to follow me on Twitter, you can search by using my tag tvart1 or by my name. Let's get started. So digitalization or digital transformation, I guess, would be the correct term to use in English. This is how we see it, and today we usually talk about digital labor or digital workers, which implies to workers that have an understanding of what they are doing, fully digital, fully AI-based workers that can emulate the things that humans do on computers or in decision making or in as part of some kind of process, and this is how we see that the components that we need to automate sort of the routine tasks that people do in their job, in their daily life. We need to emulate the brain. It has two sides. There's the left brain, which is rules based, and that's what computers have been traditionally quite good at. So you can write logic, you can write certain rules that happen when something else happens, and check the conditions and then do something. That's nothing new. Right brain is cognition based, and that's getting more interesting. So that requires some kind of deduction of things and something that you can draw conclusions from a large material of data or something that you see or something that you hear and act based on that. Thirdly, we have the eyes. In digital services, they represent data capture, so we can take a look at a form or a letter or something that we have received in physical form, picture, text, whatever, and interpret that, and maybe draw some conclusions then with our brain or the AI behind it. And then we have ears and mouth, so that's the speech and voice part. And actually, I was planning to call Watson in a minute, so I don't know how. Usually I ask this question up front, but now I can't see your hands. But anyways, the question is how many of you have heard about, well, IBM first. I think many people maybe have heard of us being one of the top tech companies in the globe. And secondly, how many of you have heard of Watson, which is our AI program that's been active for the past decade almost now. So in 2011, Watson was created, and we did the first bot, if you will, human emulation that was able to interpret questions presented in the TV show Jeopardy in the US. So actually the Watson AI went on to win the whole season of Jeopardy that season, and the challenge there being, exactly this, interpreting what's being said and catching the sort of hidden meanings behind the question, and then analyzing possible answers and picking out the best one. All right, but skipping forward, I mean, we do need some kind of coordination that controls things. So we call it the central nervous system here. That's like the analogy here. So basically, we do need ways to react to things, and once we start reacting to a certain impulse, maybe given by our eyes or by something that we hear, we would be able to do maybe a more complex task or set of tasks, and the sort of coordination and orchestration of that activity happens in the, well, doesn't really happen in the central nervous system, but for lack of a better place, I mean, that's what it's there for. It's a way to control what we do. And finally, we have the hands, and in simple cases that means software robots. So we can program, or not necessarily use programming, but we can record some kind of human activity that the human is doing to access a system, to get some data, or to input some new data into a web form or other kind of application. Right, I promised that we would call Watson. Let's do that now. I mean, it's always fun speaking to AI, and I'll share the experience with you. So I'm just picking up my phone. I'm calling a Finnish number and putting on the speaker. Let's see if you can hear what's happening.
Hello, my name is Florence, and I'm a chatbot of our flower store. What is your name?
My name is Peter.
Nice to meet you, Peter. How can I help you? Your conditions.
I would like to buy some flowers, please.
In general, I'd recommend to check the What's Trending Now page on our website, flowers.com. You could also ask recommendations for special occasions, like flowers for birthday.
I would like some flowers for a wedding.
For wedding, I'd recommend to check our wedding selection on our website, flowers.com.
All right, thank you.
You're welcome, Peter. Please let me know if you need anything else.
All right, I'm going to hang up now. And that was a bot kind of advising me on the task of buying flowers. I do have that access to that same bot here, so I can, at some point, I can give you a brief glimpse of what it's able to do and how we are able to control what it does. So that was kind of an introduction to the first topics that we need, first skill that we need in AI to do that kind of things. So speech and AI, that's actually a picture of a service called Watson Assistant. You can find it on IBM Cloud. If you have access. If you don't have access, you can register and try it out for free. It's basically a tool to program, not program, it doesn't include programming, but you can configure chatbots in there. You can define different kinds of intents, and you can define different kinds of entities that you want to recognize, and then have a chat with the bot. Also, you can kind of configure a dialogue of how to proceed with the discussion. Actually, I had a dialogue with the bot on the phone just now, so that was I'll show you in a bit. Then we do have different kinds of use cases. So here's actually a big picture of something that the a customer call center agent would be looking at this kind of screen. So it's kind of small, but on the let's see. On the left side here, you have the text version of what the customer on the phone is saying. It will iterate everything that's being said into text, and based on that conversation, whatever the problem with the customer is, it will identify that problem and kind of figure out what he's talking about, and then go and fetch relevant data from their document repository or kind of their library of documents that will tell you what to do when a customer is calling in and complaining about the bill or whatever. So that's the one kind of use case of helping out customer service people. Yeah, that's basically what I've been saying. We do different kinds of use cases. Chatbots is one of the most used ones as of right now when we are starting out. Our view on chatbots is that they should be understanding and speaking natural language, whether you type or you talk. You use your native language, and well, in my case, we were using English now. Pretty much everything I'm doing can be also done in Finnish. It's not a problem. There's no official support for Finnish in some services. In some services there is, but we've been able to do just about everything we need in Finnish and Swedish and English. One of the options is to transfer the conversation to a human agent if we need to do that. So if the customer's asking something difficult, then we can just move him to a human agent who will take care of the sort of more interesting things. If he's just asking the sort of standard questions or wanting to do a standard service, then the automation, the automated chatbot can probably handle that case. Services these days can be voice enabled, like I just showed. We have different language interpretations that can, or let's rephrase that, not interpretations. We have language recognition, so speech recognition to make text out of what I'm speaking. And secondly, we can use voice synthesizers to speak out whatever the bot is saying. And then we can also, like I just did, we can automate all of this over the telephone. So that's one good thing. The nice thing about all of these bots and telephone services is that we can use the best experts in any field to kind of work with the bot and make it understand and act like the best expert on that topic. So we can capture that knowledge and automate that into the chatbot and kind of make that available for everybody, every citizen or every customer. And then we have the assistant cases where the bot is only helping the human agent who is talking to the customer. That's one way of working. It can save a lot of time and effort to and fetch the right information and kind of understand what's going on. We still have the human interaction in front, so that's of course one opportunity to make it work. And of course we can do plug this into email or text messaging or WhatsApp or whatever. Right. Okay, I seem to have some slides which I wasn't really prepared for, but it's a good demonstration of how we interpret natural language. So the customer may be coming in saying, I'm frustrated, haven't been able to log in. And he mentions an online billing system, so we can kind of, from that we can get his intent. He's probably looking to reset his password because he says that he's not able to log in. We can find the system that he's referring to, online billing system. We can detect emotional tone. We do this kind of scoring of sentences and kind of understand the negations and the words that he's using. So it seems that he's angry or frustrated, at least in this sense. And from other systems, we can kind of get the customer information and see that he's a high value member of this service provider. So if he's not happy, then we might want to transfer him to a really good human agent, and instead of trying to work out with a robot, unless that bot is very good and these problems are very simple. That's where we usually start from. Right, and then there's different kinds of options, so we can have a dialogue, kind of get the answer to the customer, or we can deflect or defer that to the human agent who can take care of complex things like in this case, if somebody's stolen a credit card, then might be better if a human agent asks more and gives him advice. Also, if the question is something that can be answered better with a map in this case, or some kind of navigation, then we can do that. It doesn't need to be text or voice. Well, over the phone, I guess it has to be voice pretty much, but on a chatbot, we can also provide a link or a map or some kind of other interface back to the customer. Yeah, or we can fetch some information from other systems to answer the customer better. I would show, if I had more time, that we can do this by examples. We need to figure out examples of how a customer would explain that their password is locked or whatever. So we need to have 5 to 10 examples of that, and then we can kind of get going with the machine, understanding that the customer doesn't need to use the exact phrase. So like I was speaking to the flower shop bot, I mean, it would understand if I'm not using a certain word, or if it's not hearing one of my words properly. It's based on probabilities and not exact words. Right. So we're talking about natural languages. The bots understand and find the intents, and yeah, they need to confirm the understanding if they're going to do a transaction, because these days we are getting to more serious bots which can actually do very specific transactions, like reset your password or maybe do a money transfer if it's a bank or something like that. And this is important. So we store everything that we speak, or usually the customers want to store that. I mean, we don't see it, but our customers typically save the chat transcripts for analysis, because they need to improve the bot, make it better, make it understand more, and make it give better answers, but also it can be used for different kinds of things like customer analytics and so on. Which brings me to text analytics. So this is quite an interesting topic of basically the function of getting insights from a document of text. So can be any kind of text. In the first examples, we're talking about patient care systems, which are medical documents containing diagnosis and medication information and maybe some lab tests and whatever, and we can kind of get all of that also based on doctors' interviews with the patient. We can get to his lifestyle. So maybe he smokes, maybe he drinks, maybe he has stress or whatever, and then we can kind of find that kind of things from the text. But all it comes down to is this kind of thing. So we have a document here, formal document, which has dates, which has names, and which has mentions certain topics and brand names and addresses. So we can kind of make that unstructured text into a very structured record of things. So with a name, date, things involved, addresses, and so on. And this is a good point for a demo. So let me show this. This is the Watson Assistant piece which I was going to show you. Probably don't have time for it now. Let's take a look at Watson Music Explorer instead. So this is a tool based on our text analytics capabilities, and there's actually two sides to this. The point is that it's getting all the news in real time that's coming out in number of medias around the world. So basically anything written in the internet or on the press, I think it emphasizes the ones that are coming from reliable sources. So the bigger news companies and such. But it gets everything, it stores everything, it analyzes everything, and with the help of that, we can kind of do different kinds of things. So, for example, detect some weak signals. So if we see that there's some catastrophe or some hurricane disaster or whatever, or there's some companies doing badly, or their managers have been indicted in the court or found guilty of some kind of treasons, and we can kind of evaluate what that means and maybe react to that in terms of maybe figuring out how some stocks are going to act in a bit or whatever. It's a way to analyze all of the news feeds coming in the world. So, but also, since we do the analysis, we can use the understanding that we get from all of those news, and we can do this kind of things. For example, some searches. So let's take a look at what's the relation between COVID and Finland in the press as of right now, or actually the past month. We're getting that kind of information here, and what's coming up is the sort of relationship map between my search terms. So COVID and Finland should be here, and these are the articles that mention both of them, and we can kind of find a pattern of how it's going. So this article, for example, right, it's actually from Manchester and South Australia, but for some reason it's tagged as something that mentions COVID, and it's related to Finland. Don't know yet why, but yeah, the people are there. It's about the government, and okay, could be that the link is only around the that it mentions the government, like some articles about Finland, but yeah. So anyways, for each article we do this. This is another article. So this one mentions Bank of Finland, and it mentions Xinhua, some kind of place, or actually company probably in China, and it mentions locations, Finland, Helsinki mentioned, and some topics that are linked into this article. So if I click here, I can get the full article, but if I'm just analyzing of the sort of the context around these two topics, then I'm seeing the word map here. So it's economics is the biggest thing that they are writing about in relation to COVID and Finland. epidemiology is another one. Physician, food, recession, export, and ship. Yeah, all of those probably have some relations to Finland and COVID. So, and there's actually the Viking Line ship incident has been also noticed by the press. So yeah, we can pick up on things like that. And in this case, we have taught the text analytics machine to catch place names, catch some kind of topics. We have an ontology of different kinds of topics, and we have some kind of rules of what people's names typically look like. This is interesting that in this case it's actually thinking that Amorella is a person, which is well could be, maybe some kind of rock star or whatever. And then there's some companies listed here, so it's able to identify that kind of things from a news article by analyzing the text. Right. By the way, News Explorer is available online, so anyone who wants to try it out, just find this recording and type in the link here. All right. So following news, quick signals, investigating how things relate to each other. That's what I did right now. We can make typed information out of documents and find that, and we can do scoring for different kinds of things. So we can find what's the most relevant thing, or what would be the effect of this for a certain company or whatever. For example, the Viking Line cruise problem will probably have some kind of economical meanings for that company in question. Computer vision. Thirdly, this is an interesting topic. It's a lot of things going on in this area, but what we've been mostly active with is something that we call visual recognition. So we can identify from photos, we can identify different kinds of classified, or we can classify things that are seen in the photo. And with the help of that service, we've launched something that helps identify melanoma. It's not available in Europe because it's not classified as a medical device. In Europe, we would need to have that classification, but I think they did it in Australia, and it seems to be helping in that geography where melanoma is a real problem. Also, we can do things like estimate people's bone structure, for example, in sports, and we can analyze videos, and we can the medical and physiological things are quite obvious. We can catch things on X-rays that doctors might miss, or we can at least help in those cases, because we can look for some rare forms of cancer which normal doctors usually don't even know about, and stay up to date with what's being written in medical journals and scientific articles. We can analyze traffic. We can check for free parking spaces, based on a video. That's place a camera on a parking lot, and we can tell how many free parking spots there are, and maybe publish that information online or in some map application or whatever. We can do airport security. I guess that's where it started from. The people who are looking at the videos at the airports can kind of tag certain people or select certain people, and then when he moves to the scope of another camera, then we can still follow that same guy and kind of figure out who left their bags in that place. And yeah, it's kind of important stuff at the airports that they want to track. We can also track cars and other things in traffic. So we can, if we have a video recording that is pointed at the street, then we can kind of figure out if some car is not driving on the right lane, or if it's making an illegal U-turn or whatever. So that kind of things can be done with video analytics. We can do quality control, take a look at the manufactured objects, color and shape and things like that, size and so on from live video feed. We can mine some videos for people and topics, and this applies to the YouTube feed we are looking at right now. It will probably get analyzed by a copyright bot to see that we're not using any copyrighted material in the wrong way in this video. So that's one interesting thing that is sort of trending this year. YouTube primarily has been the sort of big user of video bots searching for copyright infringements, and they are kind of sending out warnings to those individuals who post stuff to YouTube and are breaking the rules in terms of copyright. Then we have, I hope you can still hear me. I get some kind of warning of unstable network signal. This is interesting. We also did a thing with the Bundesliga football games in Germany about 2 years ago, and we deployed a service where we would automatically identify the highlights of a game, so we could figure out when a goal was scored and do the sort of X seconds before and X seconds after the goal was created, and sort of automatically generate highlights of football games and other events like that. So that's also interesting. Yeah. And teaching again is happens by example. So we can give it 50 pictures with a car, 50 pictures without a car, then we can kind of get the first version of visual classifier which understands what a car is or recognizes a car from a photo. Yeah, there's a service called visual recognition in IBM Cloud, so that's available if somebody wants to try it out. There's a demo also, but its demo is not very good at the moment, but I'll just give you a 2-second show. So give it a photo like that, it will say it's very probably has gray color, it quite probably has fabric in it. The numbers here are sort of odds or the certainty of identification. So if we are not very certain, then it will be something like 50% or 60%. It has a good idea that it's tweed, the fabric that it's in the picture, but anything beyond that is not sure enough, so it will not mention. And a couple of pictures here that you can test the service with. So we'll find colors, we'll find things that are in the picture, electrical device, some kind of conductor or electronic equipment, and so on. And in this case also, it's something that's chocolate color, probably beverage, since it's contained in a glass like that. Could be alcoholic, could be wine, or soy sauce, actually based on the color. It's quite a good guess. I have no idea what's in the picture, but sure looks like what Watson is seeing in the picture. Right, yeah, moving on, digital workers and RPA, kind of the one of the core topics today. So robotic process automation has been a hype term for the past couple of years, 3-4 years now, and it's good for automating applications and web UIs. That's what it's good for. And also, if you want to, if you have a large set of applications available in your enterprise, or you have your old stuff running even on a mainframe or in some kind of web-enabled system, then we can use those, and we can attach some modern AI, glue them on by using RPA to as the glue. So we can fetch figures from other systems, use them as parameters for our AI models, and they then get some kind of results back, which we can, for example, automatically input into another system, or maybe fill out a spreadsheet or Excel with some figures that we've fetched from a website. So we can automate that kind of repetitive tasks that are kind of boring to do, and it could be something business related. It could be something that we actually pay somebody to go and reset the password or do some other tasks on an application. But it could also be something like as mundane as finding some figures and putting them into a Excel spreadsheet, and that's as far as it goes. But in what we are now talking about is digital workers, which takes this a bit further. So the idea is that the digital workers would have the knowledge to understand what's needed and to carry out the necessary actions to serve the customer, to get a specific job done. It can take multiple steps, and it can even be that it doesn't complete in while the customer is waiting, but it, at least the digital worker can get the job started, and then it will happen when it's handled by other systems or other people. That kind of transactions are relevant, and that's where we kind of have the new sort of marriage between the chatbots and the sort of RPA or the digital worker in the background. So that's something that's trending right now, and later today I'm attending a conference on this topic sponsored by Forrester Research. So that's interesting idea. So automation, the problem is that it breaks. It needs to be reconfigured if something changes on the website. It doesn't look the same, it doesn't have the same layout, has some new input fields or whatever, then the automation typically would break, and we need to redo that to get the system running again. So in that sense, it's like a temporary or one-time solution, and if we want a more permanent one, then we would use some APIs that are built for the purpose and well documented, and that's the kind of things we would go for if we do this for real. Finally, this is my final topics. I'll be finished just in time. So data and machine learning. So that's kind of the core behind all of this. And right now we have a new hype job called the data scientist, and data scientists are people who work with the data and with this kind of algorithms that analyze the data, and they build and define services and that make something business relevant out of the data, or make deductions based on input data. So basically, I would define machine learning in a kind of the way it works would be when we have a lot of decisions. For example, it could be the loan decision in a bank, or it could be a benefit decision made by the social benefit administrator, or whatever. It could be some other kind of decision. If we have 1,000 examples or 500,000 examples of decisions made by humans, then we can use that as training material for machine learning to automate that. So that's the idea behind it. But it doesn't have to be that kind of very specified business data. It could be, we could apply it on pictures or whatever to figure out what kind of pictures are relevant, and should have a better example of this maybe, but we've had some good cases around this, and the thing is that these data scientists are spending most of their time. They're really competent guys who know statistics, who know math, who know something about the data that's been handled, and they will find more when they need to build a model. And the problem is that most of their time is going to waste when they are dealing with low quality data and which is not in the right form. So they need proper tools to organize that data. They need to be able to fill in the blanks in some cases and find better data sources and kind of figure out alternative places where they can go to find data or make the relationships between business data and for example statistical data of different towns or different countries or whatever from public sources, and get all of that in and organized in a way that they can use to teach a machine learning model. GDPR is important, so consumers in the EU are quite safe, but and I'll show you what happens when we don't when we would allow people to use our data in whatever kind of way. So take my chat transcript if I have it here. I don't. Let's take something else. Let's take my tweets. I mentioned my Twitter account, so I do some tweeting. It's mostly about technology stuff. This time it's going through my tweets, and it found over 2,000 words that it analyzed. And based on that, it looks like I'm a bit insensitive. So I'm tweeting about technology. I have to say that doesn't reflect my real personality, my Twitter account. But anyways, here's what the machine found. So I'm sensitive to ownership cost when buying automobiles. Maybe have experience in playing music. Well, yeah, I have some experience. Like historical movies. Don't know. Unlikely to be influenced by social media. Well, here's how it's used. So it creates a set of things that are useful for somebody who's trying to contact me or influence me or do marketing to me. And it breaks down my personality based on the words that I use in quite detailed level. So this is, it analyzes my needs, my values, and my big five personality traits, if you will. So I have looks like not very hedonistic based on my tweets. It's only 6%, and I'm quite open to change and self-enhancement. I guess that's what I tweet about. It analyzes my needs, what kind of things I need. Could be good for somebody who's trying to market some product to me. And then my sort of openness and agreeableness and emotional range. Kind of these features are useful for somebody who's maybe trying to do team building or HR, figure out if I'm a good candidate for a given job or something. So all of this information is available from anything we say and in chats or in you know, even over the phone, like I showed, it's all being transcribed these days, and yeah. So be careful what you say. It will be used against you in a way or another in the near future. Other interesting and important stuff that I would discuss if I had more time. Maybe next time, maybe you can contact me if you're interested in talking about this. But we do have ways to trace AI decision making. We do have ways to detect bias in decisions, and these kind of things are quite important when we are moving to a world where more decisions are made by AI. Right, I'm out of time. It's been good to talk to you, and I'm moving to this slide where we agreed that Anna will take over and maybe say some words to move into questions or closing.
Yes, thank you very much, Tuukka. It was an interesting talk. Is there a screen share on still? Yeah, everything seems good. So,
yeah.
Thank you once again. Super important. I have gathered some questions. I think we have time to take few. So I will start reading here. First question was, one of the important ingredients of good customer service is empathy towards the customer. When does AI become empathic?
I would say that empathy is it kind of reflects on the words and the phrases that we use. So in that sense, I would say that AI can be made very empathic right now. So I was talking to quite a polite flower sales agent in the beginning of my talk, and I would say that the companies who are really doing this kind of AI and chatbots, they are using professional copywriters to formulate the answers that the AI gives out. So in that sense, it's good to be work in the right way and use the right terms and words to be respectful of the customer. I know one bank customer, it's not a Finnish bank, but a European bank. They started out with their chatbot and project, and they wanted to, at first they wanted to make it a bit funny, so it would be telling jokes or some kind of gags and things like that. But pretty soon, after about 1 month of development and testing before they launched it, they decided, no, it needs to be very, very clear, straightforward, and to the point, and not do anything funny.
Yeah, usually what I think also is that we humans, we can spot who's a bot and who's a machine talking to me. Have you, can you drop some sneakiest, most human kind of example of AI? Like maybe like jokes is a really fine art.
Yeah, the thing is that I haven't been exposed to really good phone AI yet. I have heard rumors from some colleagues in the UK and so on, where they've been called by somebody who's really polite and seems to have all the time in the world to discuss, whatever, do the chit chat and that doesn't really sound to me like somebody who's measured on how many calls they do per hour. So it could be that there are some very sneaky marketing bots out there, because those guys, automated workers, will definitely have a lot of time to discuss with you and focus on your problems. So that's like one telltale sign that you might be talking to a non-human. Other than that, voices are getting better and more fluent. So what I showed in the start was quite rudimentary, but basic demo that we do, and we can definitely do a lot better these days.
Yes, and then one question about what's a news explorer. It seems a good tool to point out topics that are noticed in the press around the world. Is it possible to use this type of tool also to point out, for example, fake news or troll factories that might want to influence the outcome of elections?
Good question. Probably yes. I mean, of course, I think there are better tools for that. First of all, I think I've seen some troll detectors, and usually they take, for example, tweets, and they recognize where it's coming from, and if it's something that hasn't been released to the world yet. I think I'm following one of those sort of troll bot detectors, and it's giving me a list of troll bots once a day or so, and saying what they are tweeting about, and so that kind of tools exist. What's an Explorer could be used. What's a News Explorer could be used for that, and there's there's a service with a interface on IBM Cloud. I think it was called Watson Discovery News, where you can programmatically access that same data feed and do your own analysis programmatically and teach a system to detect some interesting or non-reliable sources. How you would want to do that, I don't know. If it's maybe just wording or whatever it's used in the articles, then it's quite doable, and Watson News Explorer or Watson Discovery News could be used as a source for that.
Yes, and then one last but not the maybe smallest question is that how do you see the future of current development of AI and machine learning? Is there some really big steps or challenges that you have to next solve? Like you mentioned about that one side of the brains are a little bit harder to copy, or what do you think?
Yeah, and a good question again. I mean, it's we are seeing the future being formed in the field of AI. So I think what you can get from watching science fiction movies is this sort of overall understanding AI, which knows everything and can answer any question, and that's not going to be real for the foreseeable future. Instead, we are seeing a lot of sort of point solution AI. So we have well, in Finland we have a couple of reference cases. The biggest one being OP Bank. So their OP Insurance actually launched Viljo vahinkorobotti, in the claims department. So a bot that will advise you what to do when you crashed into a tree, or you dropped your laptop and it broke, or you drop your iPhone in the lake or whatever. So it will give you advice in that kind of situations, and works really well. Solves 70% of customer inquiries automatically. Nobody needs to interfere with that, but it's still a limited scope of information. So we're seeing the rise of that kind of domain-specific sort of narrow scope of bots that are coming up, and AI seems to be a good tool for that. Also, when talking about machine learning models, it's simple. We're seeing that a lot of them get deployed and created to solve a certain problem, a very specific approval decision of maybe a loan or something like that. So that kind of things are simple to do, and the domain is quite narrow, but it's nothing like the wide scope, know-it-all science fiction bots that we see in some movies. So in that sense, we are seeing at the moment how future is being formed, and looks like AI is the way to go, but not as wide as we thought, back in the days when these things started popping up in science fiction movies and novels.
Thank you, Tuukka. So you say that we can sleep our nights well, that computers won't rule the world that soon.
Yes, that's what I'm saying. I didn't get a chance to show the slide I had on what's the hope for humanity, but the thing is that once we do stick to what we're good at, so human arts, dreaming and consciousness and sort of morality and that kind of thing. So that's where machines can't replace us for a long time.
Great. Once again, thank you a lot, Tuukka Vartiainen. It was a pleasure to listen to you. And it seems that we are going to end our event soon. It was great to have you here. So all who were here, you can watch Tuukka's speech on the event's webpage still 2 weeks after this. And this will be documented. It was a really interesting day, and I really want to, beside Tuukka, thank also Sitra, who had a future workshop during this same hour. Also want to thank all the facilitators who gave us almost 20 different workshops during the day. And we are gonna now soon end this live stream, but you can upload your event page inside 5 minutes, and there will be Minna Elomaa-Krapu, who is Innovations Director, give her afterwards for this whole event. But yes, thank you on behalf of me and the whole Future Areena team, and hopefully we will see you next time. And remember to go to give some feedback on events page so we can actually develop these events even better. Yes, thank you.
Thank you.
Ja suomeksi vielä tosiaan. Lopetamme tämän live-lähetyksen tässä Streamiboxissa. Jos olit YouTuben kautta katsomassa, siirry tapahtuman nettisivulle. Tulemme päivittämään 5 minuutin sisällä sinne vielä Minna Elomaa-Kravun kiitokset tapahtumasta. Ja kun menet sinne tapahtuman sivulle, käy sieltä vielä oikeasta yläkulmasta antamassa meille palautetta tapahtumasta, jotta voidaan kehittää tästä vielä parempi ensi kerraksi. Kiitos kaikille ja toivottavasti teillä oli yhtä hyvä iltapäivä kuten meillä.